Hello students, today we are discussing very important group in P block, that is oxygen family, that is group 16. Group 16, that is called oxygen family. What are the group members in group 16? These are oxygen, sulfur, selenium, tellurium and polonium. These 5 members are group 16, and this group 16 is also called as chalcogen. These are also called chalcogen. Chalcogen means ore forming. These are called ore forming elements. These are called ore forming elements. Generally they are available in the ores. In ore forms they are also available. What are the physical properties of group 16 elements? Let us discuss. First property is general electronic configuration. If you see the general electronic configuration of group 16 elements, they have NS2NP4. They have NS2NP4 electronic configuration. NS2NP4. That means how much electron in outermost shell? 6 electron. NS2NP4 electronic configuration. That means 6 electron outermost shell. 6 electron in their outermost shell. That's why these are called group 16 elements. Then atomic size. Atomic size, if you consider that oxygen is the smallest atom in this group, and their atomic size increasing from top to bottom due to decreasing effective nuclear charge, their size increases from oxygen to polonium. But if you see the size difference between last two, tellurium and polonium, size difference is very less in compared to oxygen and sulfur. The size difference of these two last element is less difference due to pore shielding effect of F subshell. Pore shielding effect of F subshell, that polonium, the size difference between tellurium and polonium is very less. Then electronegativity. Electronegativity, we know that as the nonmetals have high electronegativity, and compared to your halogen, that group 16 is low electronegativity compared to halogen, but the order of electronegativity among the chalcogen are oxygen greater than sulfur, greater than selenium, greater than tellurium, greater than polonium. That means small size, high electronegativity. Small size, high electronegativity, large size, low electronegativity. This order. Then ionization energy. If you see the ionization energy, we know ionization energy of group 15. Group 15 elements, ionization energy is greater than group 16, because already we have discussed in group 15 that they have stable electron configuration due to half-filled p subshell. So if you see the compare ionization energy, oxygen will be highest because due to small size, and polonium will be lowest due to largest size. But if you compare with the group 15 and 16, IE1, first ionization energy of group 15 will be greater than first ionization energy of group 16 due to stable electron configuration. But after loss of first electron, then it will have just stable electron configuration like group 15. So when the first electron is removed, then it will become stable configuration, that is NP3. That's why IE2 of group 16 is greater than IE2 of group 15. IE1 of group 15 is greater than IE1 of group 16 due to stable electron configuration of group 15. But IE2 of group 16 is greater than IE2 of group 15, because after loss of first electron from group 16, it attained the stable configuration like group 15. That's why IE2 of group 16 is greater than IE2 of group 15. Then electron affinity. electron gain enthalpy, electron affinity, they have all having negative electron gain enthalpy due to high tendency towards electrons, because they have 2 electron shortage. Ns2np4 means 6 electron already, they demands 2 electron, they have they have more demands towards electron, that's why they have high electron affinity. But the electron affinity of oxygen is least, although it is small size, high electronegativity, but electron affinity is least compared to other elements in group 16. Why? Oxygen has, although it is smallest size, high electronegativity, but electron affinity is least among this group due to small size, high electron density and more electron repulsion. That means electron repulsion is more in oxygen. The electron repulsion is more in case of oxygen due to small size. That's why the electron affinity is less compared to others due to more electron repulsion and high electron density. Then what are the oxidation state? Generally, as they have how much Ns2np4 means 6 electron in their outermost shell, so they shows +6 oxidation state. Maximum oxidation state is +6 due to 6 electron in outermost shell. But if you compare the oxidation state of oxygen, generally oxygen shows +2, -2 and -1. This oxidation state is shown by oxygen. Among these, oxygen shows -1. -1 is peroxide state, -2 is oxide state, and +2 is +2 only observed by only this OF2. In this case, oxygen has +2 oxidation state, and so oxygen shows +2, -2 and -1. But other elements shows everything -1, -2, +2, +4, +6 because they have vacant d orbital, so they can increase its coordination due to pair to unpaired electron formation. So oxidation state of, if you compare the stability of oxidation state, the +6 is the highest oxidation state, but the stability of +6 state is least in case of polonium due to inert wear effect. Already we have read, if inert wear effect is more, then the stability of higher oxidation state will be less. So +6 oxidation state stability of polonium is very less, that means least in compared to others. So other than oxygen, all elements shows -1, -2, +2, +4, +6 oxidation state. Okay, and stability of +6 decreases down the group. The +6 stability decreases down the group due to increasing inert pair effect. So what are the physical state of these groups elements? Generally, oxygen is gas. Oxygen is gas. All 4 elements are solid state. All are solid state because due to large size, more van der Waals force. Of sulfur, selenium, tellurium, polonium, due to large size, they have more van der Waals force. That's why they exist in solid state. But oxygen exists in gaseous state. If you compare the physical state of oxygen and sulfur, oxygen is gas, sulfur is solid because oxygen produces pi bond between 2 oxygen atoms. So exist in linear form. So it is a linear structure. Linear structure of O2 molecule. Due to linear structure exists in free state and gaseous form because oxygen is stabilized by formation of pi bond. But in case of sulfur, the pi bond is not possible between sulfur atom due to large size. Rather, it forms sigma bond, and to satisfy the valency, sulfur exists in S8, S6 form. S4 like this. S8, S6, S4, S2 like this. And your O2, this O2 is paramagnetic. It is paramagnetic. O2 is paramagnetic. If O2 is paramagnetic and S2 also paramagnetic, this is also paramagnetic. Why S2 is paramagnetic? Because the structure of S2 is same as O2. That's why it is no doubt it is less stable compared to O2, but S2 molecule the shape, the configuration is same as O2 molecule. That's why S2 is also paramagnetic. S2 also paramagnetic. And exists in S8, S6, S4 oxidation state. When it will be heated, then the chain, the cyclic structure breaks and forming smaller molecules. So these are the physical state of except oxygen, which is gas, others are solid state. Then next very important property, that catenation. We know the catenation property, this group element only shown by sulfur, because the sulfur-sulfur bond is stronger. Sulfur-sulfur bond is stronger bond. Bond is stronger compared to other elements. That's why sulfur shows only catenation property. But why not selenium, tellurium, polonium? Because they are large size, weak bond. But why not shown by oxygen, although it is stronger bond? Because oxygen due to small size, due to electron repulsion, the chain will be weaker. That's why oxygen also does not show catenation property. Only catenation property is shown by sulfur due to strong S bond. Then like these other group elements, they also show allotropic forms. What are the allotropic form of sulfur? These are called alpha, beta, gamma sulfur. Alpha sulfur is called your rhombic sulfur, monoclinic sulfur, and plastic sulfur. Alpha, beta, gamma. Out of these three sulfur, alpha sulfur is most stable sulfur, and these exist in S8. S8, that is yellow color. Yellow color of S8 exists in powder, S8 form, yellow color, solid. And S6 molecule, if you see S6 molecule exists in two form. This is the boat form. This is called boat. This is called chair. And chair form is S6 of chair form is most stable due to less bond repulsion, because one is just opposite. Two end bonds are opposite direction. That's why least repulsion, so most stable. S6 chair form is most stable. So these are some allotropic forms of sulfur, alpha, beta, and gamma sulfur. Then what are the boiling point relation among these elements? Boiling point depends upon generally the interatomic interaction, that is the covalent bond linkage between the atoms. If you see, boiling point of tellurium is highest compared to polonium, then selenium, then sulfur, then oxygen. Question is, why the polonium is less than tellurium? Because polonium, due to inert pair effect, it cannot show plus 6 oxidation state, because plus 6 oxidation state will be very less stable. So due to inert pair effect, it does not want to show plus 6 oxidation state. So its covalence is less compared to tellurium. If you compare the covalency of tellurium is more than polonium. Due to less covalency, the linkage, that is the close packing structure decreases. That's why polonium has low boiling point and melting point compared to tellurium. But why oxygen has least melting point, boiling point? Due to small size. As it is the smallest atom, very low boiling point, low melting point. But very important difference is these two, tellurium and polonium. Why tellurium is greater than polonium? Due to low covalency of polonium. Due to polonium shows low covalency compared to tellurium due to inert pair effect. That's why tellurium shows more covalency, so melting point and boiling point and also density of tellurium is more, because the closeness is more due to more covalency of tellurium. Then what are the properties? Hydrides of chalcogen family. The hydrides of chalcogen family, H2M, they produce in H2M form. What are their formula? H2O, water, hydrogen sulfide, H2AC, H2T, H2PO. These are the some important hydrides formula. Then what are the properties comparison of these hydrides? Stability. If you compare the stability, water is the most stable hydrides among the all hydrides, because OH bond is stronger than other, because due to small size OH bonding is the strongest bond. That's why the stability of water is more. Another case also, strong hydrogen bonding. Water has strongest hydrogen bonding because OH bond is more polar than other bonds. That's why strongest hydrogen bonding, and stronger OH bond. That's why it's more stable compared to others. Then acidic nature. Similarly, as OH bond is strongest bond, so low acidic, least acidic character, and HPO bond is the longer bond. That's why more acidic. This is the acidic character of H2PO is the highest due to low bond dissociation energy. Then shape. If you compare the shape, all having Ab2L2 configuration system. Ab2, according to VSEPR theory, Ab2L2, that because they have 2 bonds and 2 lone pair, 6 electron to compare with it, forming 2 bonds with 2 hydrogen, remaining 4 electron having, that is 2 lone pair. So Ab2L2 form, that is hybridization is sp3 and shape is bent, that is V shape. All having V shape, all having molecule is V shape and shape is V shape. The system is Ab2L2 and sp3 hybridization. Then boiling point. Boiling point is very important in these hydrides. Water has the highest boiling point because strongest hydrogen bond. Very stronger hydrogen bond, intermolecular hydrogen bonding water is maximum. That's why the boiling point is highest. Then H2PO. Why H2PO is compared to others? Because H2PO due to large size molecule, larger molecular size, that's why greater van der Waals force. So after water, then H2PO is coming because due to more van der Waals force. But why water is coming first? Because due to strong hydrogen bonding. Here hydrogen bonding is stronger, that's why boiling point is more. Here H2PO is higher because due to greater van der Waals force. And H2S is least. It has least boiling point due to small size, and there is no hydrogen bonding. Then reducing nature. Reducing nature also depends upon the OH bond character. As the OH bond is the stronger bond, that's why low reducing nature. OH bond is weaker means reducing character also greater. So OH bond is strongest bond, that's why weakest reducing nature. Weakest reducing hydrides is water, and strongest reducing hydrides is H2PO. So depends upon the bond dissociation energy. Lower bond dissociation energy, greater reducing character in this concept, and lower the bond dissociation energy, greater the acidic character also. So bond angle. The bond angle depends upon the size, central atom. As the size of oxygen is the smallest, so lone pair repulsion, and here lone pair force is greater than the lone pair, and bond pair also greater than bond pair. As oxygen is the smallest atom, so this type of repulsion is more. Lone pair repulsion is more, and lone pair bond pair repulsion is more, and bond pair repulsion is also more in case of water compared to other hydrides. As the bond pair repulsion is more, that's why the bond angle is more. The bond will be get separated from each other due to the lone pair repulsion and bond pair repulsion and bond pair repulsion compared to other hydrides. That's why bond angle of water is maximum. Okay, so these are some important characteristics of oxygen family. In the next class, we will discuss some other properties and the nature of compounds of these group elements. Okay, thank you.